All right, so this video, I am going to show you how you can find the slope if you're given 2 points. So I'm talking about not using the graph. So just a little bit of recap, make sure that we're all okay. The slope is the steepness of a line. It's the same thing as rate of change. And it is also the same thing as the common difference. So since we are talking about an XY graph on a coordinate plane, we always talk about slope. When we say rate of change, that's usually with word problems. And then common difference is what we say if we're dealing with sequences. Okay, so a reminder that slope uses the letter M because it's talking about the movement from one term to the next or one point to the next. And it is a fraction. And we usually say it is the rise over the run. So what you need to think about is that the rise is talking about the up and down, which is the y value. And the run, we're always talking about going right. Now, we go left if we need to go backwards, but we're always going to go up and down, but then to the right. And that is talking about the x value. So when we rise a certain amount, that is the change, which is what the delta means. That is the change in the y over the change in the x. So we say the change in the y over the change in the x. So maybe the temperature changes 3 degrees every 4 minutes. So that would be a change of 3 degrees on the y, and 4 minutes would be the change in the x. All right, so you might be saying, well, how in the world do you find that? Well, it's very simple because the difference or how much something changes, you're just going to subtract. So to figure out how much something changes going up and down, you just have to subtract the y values. And the x values, the change in that will tell you how much you're going to go right or left. So in the end, we say that slope, to actually find it, we're going to subtract the y's and subtract the x's. So we say y minus y over x minus x. Now, it's very common to see y2 minus y1 and x2 minus x1. But in a lot of ways, it doesn't matter. As long as you're consistent and you go in the same order, it doesn't matter which one you subtract first. All right, so let me show you some examples. And then I'm also going to show you just, what we're doing, but an easier way, I think, to write it out. All right, so let's say for example 1, you're given the point 3, 7, and the point 9, 2. All right, so what we want to do is we want to figure out what is the slope or what is the rate of change between those 2 points, okay? So if we were on a graph, we would just count rise over run. But since we're not on a graph, all we have to do is subtract. All right, now, there's lots of ways you can do it. I think the easiest way to do it is to just stack the ordered pairs over each other. Okay, so I'm stacking them. So I'm lining up the y's and I'm lining up the x's. So now all we need to do is subtract. But when we subtract, we need to remember that we're writing this as a fraction. All right, so I'm always going to subtract here first. These are my y's. 7 minus 2 is 5. 3 minus 9 is negative 6. So the slope is negative 5 over 6. So it doesn't matter if you write the negative down there or you write the negative down there or you write the negative out in front of the entire fraction, there's only one negative per fraction. All right. And the reason is because we've had two negatives, we'd make it a positive. So there's our slope. All right, let's try another one. So let's say, for example 2, so here we go, example 2. All right, let's say we have -4, 3, and 5, -1. All right, so we are finding the slope. So we need to do rise over run. And again, we can't go through or on the graph. We're just going to subtract the points. All right, so first thing I'm going to do is just stack them. And it doesn't matter. You can do this either way. So whichever one first, it doesn't matter. But I am stacking the x's and y's over each other. So I'm just stacking. So I kind of joke and say we need to stack and subtract. All right, so be careful. So 3 minus -1. 3 minus -1 is 4. So you got to remember your positive and negative rules. So 3 minus negative is going to be a plus. And then we have -4 minus 5, which is -9. So again, however you want to write that, the slope is -4/9. All right, so all we're doing is stacking and subtracting. That's it. All right, let's try one more, and then I'm going to show you 2 special situations involving 0, because when we get 0, it's a problem. Well, it's not a problem. I shouldn't say that. It's not a problem. 0 is not a problem. Okay, let's say we have, how about 2, 7, and 6, 15. I don't know. I'm just making these up. All right, so first thing we're going to do is stack them. And again, it doesn't matter. So you decide. Like, let's say on this one, you want the larger numbers and that it doesn't matter. So I'm just going to do 6, 15, and we need to subtract 2, 7. All right, so again, when we subtract, we always start here, which is a good way to remember that the y's go on top. All right, so if we do 15 minus 7, that would be 8. 6 minus 2 would be 4, but we can simplify that. That would simplify to be 2 over 1, which is just 2. So for this answer, the slope is 2. All right. Okay, so all you have to do is stack them and then subtract them. And remember, the answer to slope is always a fraction. It's not an ordered pair. It's telling you how to move. So it's not a location, it's a movement. So this is our rise over run, and then reduce it if possible. Okay, so of course I always write too big. So let me go on to the next page to show you what happens, the 2 special cases that involve getting 0. All right, so for example 4, let's say we had 3, 7, and we'll do 5, 7. All right, so I'm going to stack them and subtract them. So I'm going to put 5, 7, and subtract 3, 7. All right, so 7 minus 7 is 0. 5 minus 3 is 2. All right, so now we have to ask ourselves, what does this mean? What happens when 0 is in the numerator? Well, the answer is 0. So if 0 is in the numerator, the answer is 0. Okay. All right, so let's try the other one, and you can probably guess what I'm going to do here. So for example 5, So let's say that we have the point, oh, let's do 3, 7 again, but this time let's do 3, 9. All right, so to find the slope, all we need to do is stack them and subtract them. That's it. So 3, 9, and I'm going to subtract 3, 7. All right, 9 minus 7 is 2. 3 minus 3 is 0. All right, so now we have to say, well, what happens when 0 is in the denominator? Well, 0 in the denominator isn't possible. You can't divide by 0, ever. So in this situation, the slope is undefined, which means there isn't an answer for this problem. All right, now you might be wondering, well, what does this look like on a graph? So on a graph, if the slope is 0, you're going to end up with a horizontal line. So if the slope is 0, you get a horizontal line. And if you think about it, what's the steepness here? It's not going up, it's not going down, it's just flat. Okay, so that's what happens when slope is 0. When slope is undefined, this is a vertical line. And there's lots of ways to remember this, but the bottom line is, if you think of a ski slope, you can ski any kind of slope except a vertical one. So it's not exactly fun walking on skis, but it's possible. But you can't ski a vertical slope. It's impossible. So when 0 is in the denominator, it's undefined. Now, I have a sign in my classroom. So just to make this point, because this is huge, and this might be very, very, very helpful, if you can remember, this is okay, but this is no. So if 0 is in the numerator, the answer to that is 0. But if 0 is in the denominator, this is undefined. So it is okay to have 0 in the numerator, but having 0 in the denominator is not okay. That is when you get an undefined answer. Okay, so again, just to recap, you're finding slope, which is just a matter of subtracting, and we're subtracting y minus y on the top, x minus x goes on the bottom, and then reduce it if you can. These are the two special cases.